Right, folks, limiting reactants. A reactant finishes when one of the reactants is all used up. The other reactant has nothing left to react with, so some of it is left over. The reactant that's all used up is called the limiting reactant. The reactant that is left over is described as being in excess. The mass of product formed in a reaction depends upon the mass of the limiting reactant. This is because no more product can form when the limiting reactant is all used up. We can use calculations to work out which reactant is limiting in a chemical reaction. So if you've got 4.8 grams of magnesium and 7.3 grams of hydrochloric acid, which reactant is limiting? Well, we've got masses, so let's turn those into moles first. We've got 0.2 moles of magnesium and 0.2 moles of hydrochloric acid. Let's look at the balance symbol equation to establish mole ratios. In the balance symbol equation, 1 mole of magnesium reacts with 2 moles of hydrochloric acid, but we don't have 2 moles of hydrochloric acid. We've got 0.2 moles of hydrochloric acid, and only 0.1 mole of magnesium can react with 0.2 moles of hydrochloric acid. So in this particular scenario, the hydrochloric acid will be used up or limiting, and the magnesium will be in excess or left over. Okay. Right, now these limiting reactant calculations are definitely higher, grade 7 to 9, depending on how difficult they are. But when you're approaching the questions, if you can just remember to do some of the key points, then look, there's 6 marks for this question. Take your masses and divide them by the relative formula masses, and already you've got 2 marks out of the 4. Even if the whole mole ratio thing confuses you. However, the ratio of zinc carbonate to hydrochloric acid is 1 to 2. You don't have 1 to 2. You've worked out 0.05 to 0.05, which is basically 1 to 1. And only 0.025 moles of zinc carbonate can react with 0.5 moles of HCl. So you will have 0.025 moles left over, and zinc carbonate is in excess. Okay. What mass of zinc chloride would you expect to make? Zinc carbonate to zinc chloride is 1 to 1. So 0.025 moles will only form 0.025 moles of zinc chloride. And then you just do mass equals 0.025 times 136 equals 3.4 grams of zinc chloride. Okay. 2 more to do, folks. I've given you the balance symbol equation for this one. Pause, try the calculation. You should have 0.2 to 0.6 moles of aluminium. Mole ratio of iron oxide to aluminium is 1 to 2. The one we've got is 0.2 to 0.6. So clearly your iron oxide is going to be used up and your aluminium is going to be in excess. Only 0.4 moles of aluminium can react with it, so iron oxide is limiting. Maximum mass of iron that can be made. Okay, well, we have got aluminium to iron is 2 to 2. Okay, we've only reacted 0.4 moles of aluminium, so 0.4 moles of iron is made, and 0.4 times 56 is 22.4. Okay. Last one, folks. Pause the video, have a go at this one. Start again when you're done. And we've got that many moles of copper oxide. That many moles of carbon. Mole ratio, copper oxide to carbon. We've got 0.05 moles of copper oxide and only 0.025 moles of carbon can react with that, although we've got 0.1 moles of carbon. So copper oxide is used up and limiting, and carbon is left over and in excess. What mass of copper will you make? 2:2 mole ratio, copper oxide to copper. We've got 0.05 moles of copper oxide, so we'll have 0.05 moles of copper. 0.05 times 64 is 3.2 grams. And we are done.